Meet go, meet you live.
I stopped posting the links, because I think I'm chatting. I was like, no, don't stop posting. You love it. And I'm like, okay. But I feel like I'm the only one posting. No.
Okay. What's the next one on technology? I'll reply publicly.
I can say that, Arby, we love your links. Eric said that. And then, Eric called.
Yes.
He said, Arby, we love your links. Okay. I'm always never mind. It's fun, right?
Yes.
It's fun.
I should introduce that.
Did you meet? I need to find Dan. Dan Shaw? Dan Shaw, yeah. You gotta connect with him because he's gonna drive he's the plan is to build people used to have some. People used to have some. And so I invited him to go because I'm like, I mean, yeah, that's a role that I was offered, which I turned down. Recently, because I was offered.
You did? You would be awesome.
I want to finish 1 year. So I need to find Dan Shaw. So
I haven't met him in person yet.
Um, I don't see him. Hello? Yeah. Did it work? Yeah. Did it work? Hello? Yeah. No, it didn't work. It's working.
I am, but I don't.
Yeah, submit the talk. There's a link. Hey Dan, mic for you. I think we're pretty good to start whenever we're ready. T-shirt. What do you think?
Yeah, so we have, three 45-minute talks, right?
We have 3 45-minute talk. We don't have one speaker yet.
Okay, well let's wait until he knows.
Let's wait till
Have you heard from me now?
Yes, he said he just texted me. He said I'm good at about 6:30. Traffic is tough like you expected, and I told him traffic would be hard. So
You ready
I
to
can
go
ask him.
up and give the wire talk?
No.
No?
Ross said he could wing it, but he doesn't have slides.
Dependency injection as interpretive dads.
Yes.
Nice,
I
nice.
think-
If it's going to be roughly at this time,
And he should be here. I mean, usually I think people are still coming in, so I think it's okay.
Okay.
is your normal start time?
Yeah,
This is
I
start
mean,
time, right?
Yeah, 6:30, 6:40. I usually start. Today traffic was really bad, so
The rain with some parts of the valley. Was
I
really
did
heavy.
good food. I didn't overorder. Rather underorder. That's okay. But yeah, did you eat? No. Okay, good. I haven't eaten.
You put us to shame when you told us that.
Yeah, this is yeah, team went all out, so it's fine. Yeah, we could start as soon as he arrives.
I mean, you only doing that when the first talk's going
So
on.
we have the first talk. We could have Deepak.
I'm gonna give 5 minutes.
We could have Deepak.
All right, so we're gonna get started here in about 5 minutes. Now's a great time. We have Go t-shirts over in the corner, so if you haven't gotten a t-shirt and you wear a large or an XL, we have larges or XLs. If you wear not that, sorry. Right. Please don't take the Gophers though. Let me have my Gophers. You have a chance to get a Gopher, but these are fun for us. So I have some Gophers. Hopefully no one will get hurt. We'll get started in about 5 minutes. Okay? Thanks. I get more amplification? All right, Jamin's here, so we can get started. As soon as he sits down, we'll. How's everybody doing? The rain was okay getting in? Come on in and sit down. The beverages and the adult beverages are over here. Please grab something to drink and eat. Have a seat. Make yourself at home. So welcome to PayPal Town Hall. I'm Dan Shaw, Global Head of Developer Relations here at PayPal. Very happy to host tonight. I am the Node guy. So I've been in Node for a decade and went really deep down that rabbit hole. And just recently joined PayPal. Artie was gracious enough to invite me and bring me to come and share. So please don't hate me. I've been chairing a security working group inside the CNCF for the past year, so I've been very close to Go in that, and I appreciate y'all having me and inviting me to participate here. So before we get started, I wanted to allow folks that are potentially exploring options to self-identify, and I wanted you all to get a chance to identify the hiring managers that are around tonight. So maybe we'll get started. Our hiring managers, if they could raise their hands. We have a few of them here. So these individuals are looking for folks, and we'll have a few breaks tonight. So as you're getting a beverage, they're good folks to talk to. Let's do the inverse. Folks that are looking tonight, if you want to self-identify, please feel free. If not, go hit up the hiring managers. Great, fantastic. We have a wonderful lineup tonight. We have three amazing speakers, and we're going to go through kind of a broad spectrum of APIs and dependency injection in Go, and then we'll round out the evening sharing some of the interesting Go work that we're doing here at PayPal. So I want to kick off tonight with our first speaker, Nick Snyder of SourceGraph is joining us, and he shared with me before we got started that he's really big into sailing. So the water that we've had allowed him to sail over here to PayPal today, and really excited to have Nick come up and kick us off today. Ready to go? All right.
Thanks. Let me pull up my slides. Cool. I'm Nick Snyder. I'm from SourceGraph. It's nice to see all of you here. Today I'm here to talk about breaking changes, how to maintain a library and make changes to it, and sometimes you have to break your API. And so how do you do that well? I want to share some of my experiences as a library maintainer myself and talk through what it means to evolve your library. So a little bit of background. In addition to working at SourceGraph, I maintain a open source library called Go IETN. It's a localization library. It helps you manage translations for your Go program. The first commit was in 2012, and this was right around the time that Go 1 was released. And I tagged version 1 of my library in 2015. The API had actually stabilized a year prior, but I didn't know it was stable at the time, so I kind of retroactively tagged it V1 a year later. And since then, I've released 11 releases of the library with non-breaking changes, and so it's grown over time. And in February this year, started working on V2. There was a kind of small but growing backlog of issues that people, features that they wanted and bugs that I wanted to fix but would have required breaking changes. So I was thinking about, how can I do that in a way that's not going to cause people a bunch of pain? As of right now, I have version 2 of the library still in beta, but probably will release version 2 soon. And the rest of this presentation will just be talking about breaking changes in general, how that applies to Go specifically, and some of the things that I learned on the way. So first, let's talk about what is a breaking change. And in broad terms, a breaking change is a change that potentially or actually causes other software to stop working. This can mean that existing code no longer compiles. It also might mean that the behavior of the code changes such that programs that were operating before operate in a different way. And if the original user wants to maintain the existing behavior, they need to make a change. So to be clear, there are two kinds of breaking changes. One is the unintentional breaking change. This is usually a bug, and the solution is just to go fix it. But what I want to talk about is intentional breaking changes. So you're evolving your API. You want to change how your library works, and that's what the rest of this presentation is about. So a good place to start is, how does Go deal with breaking changes in compatibility? We can look to the Go 1 compatibility promise, and I've highlighted the most important parts, I think, here on the slide. The gist is that Go 1 is intended to work for a long time. It's been 10 years, or almost 10 years, I guess. And the goal was to have Go 1 work for 10 years. And there have been talks about Go 2, and we're designing Go 2 for the next 10 years of software development. So the point is, we want our software to be stable and be used over time so people can depend on it, people can rely on it, without having to deal with a lot of maintenance issues. That said, there are exceptions to Go 1 compatibility. And here's an enumerated list. And these can apply to your own personal library as well. Security changes, like if a security bug is discovered, you might need to fix it. And that might involve a breaking API change. Unspecified behavior, if something wasn't clearly defined and you realize, oh, I need to throw an error in that case, or we need to panic because that's just wrong, you might need to make a breaking change. Specification errors for the Go language, this may not apply to individual libraries, but they reserve the right to fix those. Bug fixes, like your library may have intended to behave one way, but wasn't actually behaving that way. So it makes sense to fix it. There are a couple of things. The next two things are kind of perhaps unexpected. Usually it's safe to add things, and that won't break. There are some cases in Go where if you add exported fields to a struct, or if you add exported methods to types, then it's possible, if someone has embedded your type in their structure and they've embedded another type in that structure, that your new name will collide with an existing name on that embedded type. Go 1 states that they're not going to worry about this. They think it's okay to add new things, and if your code base happens to have a conflicting name, then that's rare enough and easy enough to fix. So it's not something that they're going to worry about. Last two things, dot imports. You can dot import a package so that you don't have to specify the package prefix when using symbols from that package. Obviously, if you do this, you're taking all those symbols and putting them into your namespace, so that can cause conflicts. If the library that you're importing adds a new symbol that conflicts with the name that's already in your namespace. Generally, you don't use dot imports in regular programs. You might use it during tests for convenience, but that's another reason why Go 1 doesn't worry about breaking compatibility in that circumstance. And finally, package unsafe, kind of by definition, is unsafe, so there are no guarantees there. And I want to quickly go back to the Go 1 compatibility promise. It explicitly states that although these expectations apply to Go 1 itself, they hope that similar considerations will be made for the development of externally developed software based on Go 1. So that's kind of what we're going to talk about, too. So to be a little bit more concrete about what is a breaking change in Go, here's a list. Generally removing anything that's exported is a breaking change because someone might be depending on that. And if you remove it, then their code's not going to compile. Adding a method to an exported interface. Obviously, if someone has tried to implement that interface and you add a new method to it, suddenly they will not be able to pass that structure along through as that interface. And making any change to an exported function or method signature. This even includes things like periodic arguments. It might seem like it's okay to make a change, but if someone has saved that function to a variable and passed it around, then the type is actually changed too. One reference here is this blog that I nicely compiled this list and also has a more in-depth explanation if you're interested in checking that out after the talk. So what are compatible changes? Basically, any change that doesn't affect the exported API and doesn't change observable behavior. That's kind of obvious. There are also three other things which you can do, which involve exported types, adding exported function type variable constant at the package scope. Again, generally this is safe unless someone is using dot imports, which the Go1 compatibility promise says we don't need to worry about. Second thing, adding an exported field to a struct. Again, that's safe, assuming that we're not worrying about name collisions, and adding an exported method to a type. So the summary here is don't remove things, and generally it's okay to add things. So why do we want to avoid breaking changes? One reason is that it increases the friction to update to the latest version. Your users have to spend that much more effort when they want to update, and this means that they're going to be delayed if they want to get the latest bug fix or the latest feature in your library. They're going to have to do a little bit of extra work, so it might cause them to put off doing that update. They need to fix the compile errors that happen. They need to adapt their code to new behaviors. They might not know if any behavior has changed if you release a major version. They might be worried that things have changed, even if things haven't changed. So they need to go through all of their regression tests and all that stuff. So, making a breaking change makes your library less accessible to users. Another reason, it fragments the ecosystem. Third-party information about your library and how to use it becomes stale, and there's not an easy way to update it. These might be recorded tech talks, articles, Stack Overflow questions. Anytime you make a change to your library like this information becomes out of date. And it can make newcomers confused about how to correctly use your library. A third reason is it can discourage the use of your library to begin with. Frequent breaking changes to a library might be a signal that your project isn't ready for production. You haven't quite figured out what problem you're trying to solve. And it might be a signal that, if I use this library, then I'm going to have to spend a lot of maintenance time updating the library and updating my code to support the new library changes. And it gets very painful if you have a large code base. All of this decreases the net value of your library. Ultimately, people use your library because they want to save time, not spend time. So if you increase the amount of time that people have to spend just to use your library, then you're decreasing their net value, and they might be less likely to use your library. So we've talked about what breaking changes are and why they're bad. So how do we avoid making breaking changes? One simple thing to do is just to keep your exported API as minimal as possible. A small API is, easier to learn, easier to understand, and easier to use to begin with. So it's just good design. But also, it's possible to add API later. If you have built a nice small kernel of your library and you get people to start using it, then they'll tell you what's missing, and you can use that information to help guide the additions to your library. You're always going to have more information in the future than you have today about what's the right way to design your API. So it's good if you can defer making those types of decisions. And if you do need to change your exported API later, there's less to break. The less there is, there's less to break, and there's less confusing interactions. So keeping your exported API as minimal as possible and gradually evolving it over time will help you avoid making breaking changes. Another thing I allude to is just shipping to real users as soon as possible. They're the users who are going to tell you what's missing. Once you have this kernel of your library, they'll start using it. And if they don't start using it, then maybe it's not useful. And if they do start using it, you'll have honed in on a real use case. And then you can get real feedback from those users about what's useful, what's not useful, what's the next most valuable thing to add. And this saves you time. You don't want to waste time writing a bunch of code that no one is going to use or is not going to be happy using. So launch early, iterate. And finally, when you are working on your API and you're evolving it, add things. Don't edit things, don't delete things. As I said before, deleting or editing APIs results in breaking changes, but generally adding new APIs is safe. Sometimes the difficult part here is choosing names. There's a temptation to just edit, edit the function signature. But if you want to be compatible, you need to create a new function, and that function needs to have a different name. So this can be the difficult part of choosing a new name, but it's worth it for not breaking backwards compatibility. The other thing that's useful about not deleting is if you do add API and it allows your users to gradually migrate to the new API. The old API is still around. New call sites can be updated. If you have a large code base and hundreds of call sites, you can update them one at a time. You don't have to, update to version 2 of the library and in one commit change all the functions. This gives the people who depend on your library a grace period. And then later, if you want to make, tag v2 and remove all the deprecated stuff, you can clean all that up later. So we've talked about, breaking changes, what they are, why you should avoid them, but why might you want to make a breaking change? Sometimes they happen and they're necessary. Here are some reasons that I think aren't good. Renaming APIs when behavior isn't changing. Stick with what you have. It's what people are used to and it's what works. Changing it will just break people for no reason. If you have a slightly better name for something, you have regret that you named it something, well, maybe batch that in the future when you make other changes to your API, but don't worry about it now. Reorganizing code. We all like to keep a nice, clean code base. The problem is that this changes the import paths, which would be backwards incompatible. So again, stick with what you have. It's what people are used to. It's what works. And anything else that isn't directly tied to the needs of the people who are actually using your library. If you're making changes for yourself, then it's probably not a good reason to break your library. If you're making changes for users, then it's probably a good reason. And the good news is that if you have these reasons for wanting to change things, you're not out of luck. You should just wait until you have good reasons to change your API and then batch these kinds of changes with those changes. So let's talk about good reasons. One, fixing security issues. Like we already mentioned with Go incompatibility, I don't think anyone will be angry with you if there's a security issue in your library and you have to break an API to make it safe to use. And second is just adapt to the new requirements that aren't possible to satisfy with your existing API. Users may be requesting features that you hadn't anticipated when you first wrote your library. There might be bugs that were unforeseen and flaws in your design that you need to correct in order to make your library work the way that you intended. These are good reasons to change your library and change your exported API. The important thing here is it's based on real user feedback. So when is the best time to make a breaking change to your library? In short, I think it's when you're confident that the breaking change is a net positive for your users. And I think there are a couple bullet points here. When you are proposing a new API or proposing a breaking change to your library, you want to make sure that feedback about that new API is positive. You want to shop around your API, push a work in progress branch, tag a beta release of your API, get people to start using it, trying it out. This takes some time and patience. It also takes some effort. So be willing to spend some time putting it out there, not immediately tagging v2 and letting people play with it, letting people experiment with it, letting yourself think about it over time and evolving it based on feedback. The other thing is, if you anticipate the design to be robust to future requirements, if you're confident that the new API you're about to propose will live and satisfy things that you haven't foreseen, you want to think ahead to make sure that the breaking change you're making now isn't going to you're not going to need to break that API again in 3 months just because some new feature happened. So think ahead. And a way to deal with this problem, it's hard to predict the future, but you can look back to the past and let these issues pile up over time and say okay, I've had my users have identified this set of issues with my library, I can make one change and it's going to solve all of these issues holistically and hopefully give me a better foundation for my library in the future. So this is the third point, batch your incompatible changes together. It gives you a chance to not just solve targeted problems one at a time, but really take a step back and holistically evaluate your library and the API and adapt to new requirements. Feed two birds with one seed. So you're ready to make a breaking change to your library. How do you go about doing that? The first step, it's always good to assess the impact of your change. And SourceGraph can help with this. So I'm going to talk a little bit about SourceGraph and how you can use SourceGraph to help evolve your API. The first thing that SourceGraph provides is code intelligence on Go code and other languages, which can help you identify how people are using your library, how many people are using your library, and which symbols and interfaces they're using from your library. SourceGraph gives you go to definition, find references, find implementations to interface methods when you're viewing code on SourceGraph or when you're viewing code on GitHub or other code hosts through our browser extension. So you should check it out. Well, I had a video to show you, but it looks like that is not going to work. Yeah. Yeah, let me see if I can show you the video. Oh, yeah. Duh. Yeah, so SourceGraph, we have two big products. One is code search. So if you install you can like Docker run, just like safe payments. So you can Docker run SourceGraph, connect your private code to it. You'll get code search, which is regex-based code search. You can install our browser extension, and that will, when you're viewing code on GitHub, show you hover tooltips. When you're hovering over code, you'll get buttons like go to definition, find references. All right, so let's see if this works. So here I'm in Gorilla Mux, which is a routing library, and I've clicked find references on the router struct, and SourceGraph has given me local references. But we also have external references. So this is SourceGraph's product, and I just went to view the usage of router in our code base. I'll go ahead and play that again. So SourceGraph can find references within a code base, but also other code bases that are on your SourceGraph instance. So I can search and see like where in the SourceGraph code base are using Mux router, and then if I'm looking at SourceGraph's code and I see us using Mux router, I can quickly jump back to the definition. So the second thing we have is code search. And this provides a powerful regex-based code search across all of the code you care about, and this works for any language. And one example is Rust frequently cites SourceGraph search results as evidence for language changes that they're about to make in their proposals. You can check out their Rust-Lang RFCs repo and search for sourcegraph.com and see all the issues where they've linked to SourceGraph. Also give you a demo of search in action. So for this, I was looking for how Hugo uses my Go library, and I'm looking for how they use my bundle. Actually, I'm going to slow this down a little bit. So first I search for bundle, I get a bunch of results, and I see there's results from tests here. I want to exclude those, so I exclude the test results. And then I also see there's like markdown files. So I click the markdown chip, and I put a minus in front of it to exclude markdown files. And then I'm looking through, and I'm like, oh, I'm still getting like dot comments, so I want to make sure it's like bundle dot something. And I get like bundle.js, which isn't what I want, so I add a regex filter. I want it followed by a capital A through Z, so it's an exported use. I want case sensitive, so I'll do that. And finally, I'm getting the results that I want. And it shows all the usages of my library, bundle.SumExported symbol in my library, quickly jump to definition, and now I'm inside of my library, finding, looking at hover tooltips, finding references, jumping to definition. So that's how SourceGraph Code Search can help you find how your library is used and find how your library is used, and also find usage examples. If you're using someone else's library, how are other people using this library? And it gives you good examples to replicate in your code base. Cool. So you've decided to make a breaking change to your library, you've assessed the impact, and now you're ready to go do it in Go. How do you go do that? You have a few options. Option one is to create a version subdirectory in your Git repository. Here's an example here of what I've done with Go ITN. I have my original code there at the root, which is how I checked it in, starting in 2012. And I didn't want to move that because that would break older usages. Anyone who's just using vanilla Go Git can't move the code, so we have to keep it there. So for all the new code, I created a v2 subdirectory and put my Go mod file there, and that's where it lives. I like this because it's compatible, it keeps all the code on master, and it's easy to maintain both versions at the same time. There's actually a second option too, and that is just to do an in-place update. So you have your go.mod file, you say it's version 2, and you just overwrite all your code with all the version 2 code. The one downside here is that it'll break anyone using Go Git with Go less than 1.11. There is a fix, fortunately. It turns out that Go Git prefers to pull code from a branch named Go1. So if you push all your current code to a branch named Go1, then all of your old users will happily keep using that version of the code, and you don't have to deal with the clutter of old versions of libraries in your master branch if you don't want to. And then when you do v3 and v4 and all that stuff, you just update your code, you update the Go mod file, and you're good to go. And lastly, as you're developing this, your new library, the important part is to communicate with your users. Create a collection of issues that you want to solve, not only for yourself, but so everyone else knows what the expectations are for the next version you're going to release. It's useful. I found it useful to either use a label or a GitHub milestone to keep all these things organized. And I also used created a tracking issue to communicate frequent updates. So the issue is called release v2. And I post an update for my plan, and when I release new beta versions, and people can subscribe and get updates and ask questions and comment on the process itself. As you're developing your new API, remember to publish beta versions, have people try it out, solicit feedback. Again, this takes time. No reason to be in a rush. And finally, when you're ready to tag the final release and you've addressed all the relevant feedback, tag it when you're confident that you don't need to make any more breaking changes. You don't need to get everything done as long as what remains won't require any breaking changes. So in summary, start small, share your prototype early to get feedback, make breaking API changes sparingly, prefer just adding new API. And when you do make breaking API changes, make them for the right reasons, assess the impact, and publish to a new import path using Go modules. SourceGraph loves Go. We use it in production. We're hiring. Let me know if you're interested. And thanks. Do we want to do questions now?
Do we have any questions? I have gophers. First question gets a gopher. Let me come back and... Sorry.
So the question is more about vendoring and how do you handle versioning versus vendoring? Generally, people do vendoring, and that's a common practice that people follow. At least I follow that way.
Yeah. Vendoring doesn't really change the equation as far as breaking changes go. It allows you to control better when you update. With Go modules, I don't think it is as important. Like, you can verify that what you get when you download a Go module is the same as what you expect. The GoSum file can verify that for you. I think vendoring is more of an optimization to prevent you from re-downloading things over the network or being able to make a build offline. And you can also achieve things like this with the Go module proxy like Athens.
Great.
So imagine you are writing a new library, and you know this is going to be a long-living library that will go through many versions for various reasons. Now, when you are starting, would you prefer to immediately give it the name V1 and use semantic import with that? Or would you just do without the name and then bump up the name later?
It depends. I think there's always a phase of development where you're still figuring out what you're building, and until you are confident that you've reached that kernel of your library, it doesn't make sense to tag a V1. But basically, you should tag V1 when you've reached a state where you're actually using it in production or you're actually using the library and people are depending on it. There are some popular frameworks that have started with like 0.1, 0.2, up to 0.15. They're like, surprise, now it's 16, version 16, right? Because really people have been using this in production for a long time. Yeah, you don't hide behind a version number. People are using it in production, it's V1.
So one more question. One more question, and spread things around.
My question is around Go releases. So when you're planning for a version, you say you have to look forward and think about all the breaking changes. When do you start looking at Go 2? I mean, right now, obviously it's not released yet, but like once it is released, you're obviously not going to start supporting it instantly. But when is the time you start saying, okay, it's released, it's stable, now I have to start looking into breaking changes that are going to affect my library and, start affecting, like, start bringing in the changes that are in Go 2? Like, when is that point?
Yeah, I think for the Go language itself, Go 2 is more of a label for features, big features that they want to add to the Go language. But in fact, the Go team wants to make those changes as additions to the library in a way that wouldn't require backward incompatibility. So I think the goal is that you wouldn't have to do any special things for the new features like error checks or generics or stuff like that, or anything else that might be added. But let's say, hypothetically, there is a Go v2 and there are breaking changes, and you have your own library that you're maintaining. At some point, you're going to want to tag a new major version of your library, probably, and make that version, that new version of your library, compatible with the new version of Go. I wouldn't do that until whatever the new version of Go is final. But you can, release pre-releases along with Go if you want. Does that answer your question?
Awesome. Well, let's give it up again for Nick Snyder of SourceGraph. Thanks, Nick. So we can take a couple minutes if you want to grab a refreshed beverage. I'm going to let Eno get settled and get set up. And quick break, 2 minutes, a beverage refresh, and then we'll get started again. Everybody.
Yeah.
So you mentioned about, let's say, if you wanted to release a major release, right? You said you also need to have the V1 code as such, and have a folder like V2 so that you can have both of these.
Yeah.
So doesn't it result in a code duplication where, if, let's say, you wanted to fix some bugs or something like that, you want to make both the side has to be done right? So doesn't it challenge for maintaining this?
So
did you face something like that?
you can actually share code between your two versions if they're there in the same branch. Like you can create a shared library that they can both depend on if there's a lot of duplication. But it kind of depends on how you want to. Let me turn off my mic.
Okay.
Hello.
Oh, no. Yeah, sorry. I've seen it was context switching, and I was like, oh, that's what you're talking about. No, like, yeah, Cass just gave us the, go first. So it's like, yeah, these are my personal. I live here. Slash. Artie, I gotta tell you this great story. I got into a lift in Mountain View. We drove, having a great conversation with my driver, and then I look out the window, I'm like, where you pick me up? Like, we drove all the way down here and somehow came all the way back again. And I was watching the map, like, I have no idea. Wow. So anyway, I'm sorry.
That's a good story. You should tell that story.
So sorry for being late.
No worries. I think that we should start with this.
Oh yeah, sorry.
Yep.
So, but then
You ready? All right. Now that we have our beverages, let's go ahead and settle down. So you're... All right, let's go ahead and get started. I'm going to start throwing gophers. Actually, no, right? Wrong incentive. Great. Well, I try to have a little bit of a funny story, but actually, I'm going to let Eno tell an even funnier story about his adventure in getting here. So, Eno Compton from Google is going to share DI with Wire. So, please tell the funny story.
All right, thanks a lot, everybody. I'm really sorry I'm late. I had this wonderful conversation with my Lyft driver, and maybe all of you have had this story. This has never happened to me. I've taken Lyft a million times. I got in Mountain View, having this great conversation with my driver. Oh, it's great. I'm going to be right on time. I might be so early, nobody's going to be there. That's what I'm thinking. And then I look out the window. I was like, isn't that where you pick me up? We drove all the way down here and somehow went all the way back to Mountain View. And then, so that's why I'm late. I literally think it was a glitch in the Matrix. It was pretty. Anyway, I'm here. So thanks a lot for coming, everybody. I really appreciate everybody coming out. Thanks a lot to everyone organizing the meetup. Organizing a meetup's a ton of work, so thank you, Artie, and the other individuals running this. That's a huge service to the community. Anyway, so I'm going to talk about this thing called Wire. Let's see. This summer, sometime, the Go team released this thing called Go Cloud. I don't know if any of you noticed it. There was a blog post on the Go blog. And the bigger story with Go Cloud is the Go team wants to help foster an environment of portability. What that means is when you choose Go, you should have this great ecosystem that supports you such that if you want to be running your stuff on Azure, Google Cloud, DigitalOcean, whatever, AWS, you have all these great libraries that makes it very easy for you to move your infrastructure around wherever makes sense for your business, for your team, whatever the case may be. So that's sort of Go Cloud in a very short nutshell. If you're interested, I would recommend reading the blog post because there's a lot more going on than just what I said. But tonight we're not going to talk about Go Cloud. We're going to talk about a part of Go Cloud called Wire. So the title of my talk is An Introduction to Compile Time Dependency Injection with Wire. And if you read that and think, I just worked all day, I'm so tired, why do you have to use all those words? I'm just here to have fun and talk about my favorite language. You could also think of this talk as called Learn to Use Wire by Example. So this is not a super formal talk. if you have questions as we go, like feel free to jump in. I hope to speak for about 20 minutes or so, and we'll have a little bit of time for questions at the end. Also, some friends from Google are here, including Ross, who's been heavily involved with Wire. So if you have questions, he might be a good person to talk to. So anyway, let's get started. Again, my name's Eno Compton. There's my email address if you want to send me an email. I'm trying this thing where I use email as my primary means of communicating with other humans. It's much better than social media, in my opinion, but we'll see. And I've got some links. Now, if you're like me, you're like, I would like to look at this later. I don't want to have to think about all this stuff right now. I'm also Enocom on GitHub. That's short for Eno Compton. All this stuff that I'm going to show you, actually, here, let me make that a little bigger. If you want to go home and look at this later as you're thinking about it, is enocom/presentations, and then everything I'm going to show you here is right there. So if you want to jump ahead and see how this is going to end, you could look there, but so I often tell my wife, don't read Wikipedia, like let the movie happen and see what happens. So anyway, it's up to you. So I've kind of given you a rough background of what Wire is, where it came from. I mean, if you think about you're running a bunch of infrastructure on some cloud, right? And one day you decide, or your business decides, hey, we've got a better deal over here, or the team decides, hey, we really want to be running our stuff over here. The idea of GoCloud is that because you've written all these portable APIs, the only piece of your code that is actually like aware of a particular cloud is in the setup part. Imagine that being the world. Now, of course, the world's a little more complicated than that, but bear with me. You've got this kind of like one setup function in your main.go, right? Connect to the database, turn on my tracing stuff, start my server, all this stuff, and give me back like a single thing that runs my whole world, and then, do whatever I need to do with it. The idea of Wire is it will put all those pieces together for you and then make it trivial to swap between clouds. So I could show you all that, but I think honestly it's just so like, it's so complicated that it would be better to show you a very small example. So that's what we're going to do. I'm going to show you a very small and contrived, that's the key word, contrived example. But my hope is that by giving you a very concise, clear example, you don't leave scratching your head thinking, compile time to, what is that? What did he even say? You actually kind of have an idea about what this tool is, why you might want to use it, and then whether you do or not is up to you. So let's get started. So here's what we're going to do. We're going to write a very small like simulation, a CLI application that simulates an event. Now an event will have a greeter, and maybe the greeter's going to say a message. I mean, if you've done enough like little toy getting started tutorials for various languages, this is something that I see now and then. I think it's kind of nice, and that way we can take like all these big ideas off the table for the moment of, we don't need to think about REST, we don't need to think about gRPC, we don't need to think about tracing, we don't need to think about services and repositories and all this crazy stuff that we spend our days thinking about. We can just focus on what is this Wire thing and why do we care? So let me show you what we've got here. Not much. And if you're curious what's in there, not much. So let's start with a little main.go. This is why I turned the templating thing off. It's a little slow. So here we are. So first, we're going to need a greeter, right? I should also hasten to add, if you have been following along with GoCloud and Wire and all this stuff, this is basically a sample tutorial that I wrote up on GitHub. So if you've already gone through this, I'm sorry, you've probably seen it before. Hopefully, this will be interesting to go through it again. If you've not, don't worry about it. So we'll have a greeter. Let's also say that we have a message. Now, I'm going to make message a struct. Again, this is a little contrived. Maybe our message has some kind of a value in it. Whoops. Right? I don't know. Why do you need to wrap that in a struct? Don't worry about that. Contrived, remember, that's the keyword. Now we need a thing that creates a message, and that will take some kind of value, we'll say, right, and return a message type. So we're just going to get started with our dependency graph here. And that will return a message whose value is value, etc. Now we've got our greeter that's going to deliver this message. I mean, you can think kind of like our meetup tonight as an example. Our greeter is going to need to have a reference to a message, right? And we'll make a constructor. Oops. And it will take a greeter, or sorry, not message, func new greeter. Let's have it a message in here, which is the message, and it will return a greeter. Oops. Message is message. So you can see that we're kind of like building up our dependency network. Now, as I'm doing this, obviously this is such a toy example, it's kind of a throwaway. You can sort of be thinking in the back of your mind that maybe this is more like, create a database connection, then create a repository that wraps that database connection, and then create, maybe some kind of service layer that is interacting with your repository layer, and then maybe you create a server of some sort that takes in the repository. I mean, you can imagine this very involved dependency graph of some form or another. But for now, this is all we're going to be doing, this very simple event structure. Now, the other thing I should add is, I know in Go, ideally you're working with 0 values. For whatever reason, I find that when I'm writing network code or the code that I'm writing during the day, I end up using initializers, simply because the things that I'm building can fail, right? Like, maybe your database isn't available. Maybe the port that you're trying to start your server on is already in use, whatever. So that's the other kind of little asterisks to this talk. So we have our message. We have our greeter. You can see I'm kind of building this up. Let's then get to the most exciting part, the event. And the event will have a greeter. And then finally, we'll build a constructor, or we'll make an initializer. I'm spending some time in Java land, so my language might be a little confused. And this event will then take in the greeter and save it. So, let's say that's kind of what your dependency graph looks like. And again, maybe these swap out greeter for database connection, repository, store, whatever. So to get all this put together, then I have to say, well, I need to have a new message. Let's say hello, Go Silicon Valley, right? I mean, you've all written, presumably when you write a new service, microservice, application, CLI, whatever it is that you're writing, you've written something like this, right? In fact, maybe you've done it so many times that you're kind of like, okay, this is such a boring talk. What is this guy talking about? But anyway, so we got a message. We'll make a greeter. Oops. And finally, we'll make an event. Oops, let's put it here. There's our event. And I didn't define this yet, but let's say we'll have start. There's our program. And just for fun, oops, let's say, event start. And all start's going to do is, it's going to say, let's get that greeter to do what they were hired to do. We'll make a greet message on our greeter. Greet will return a message, and we'll say g.msg. So there we go. There's our very cool application. This is our contrived example. Now, when talking about dependency injection, I mean, if you're coming from a Java background, dependency injection or dependency injection framework isn't maybe a term that makes you a little nervous. But there's so much baggage there that I think it's helpful to just focus on what it is that Wire's doing. So we've got all our pieces put together. Let's make sure that it does in fact work. It does. Here's our greeter. Great. Okay, well that's not quite right. Right? Let's make a stringer message here. So we have a nice, let's see, not a greeter, sorry. We'll put it on the message. And, you know what I need to do? I just need to say return m.value. So let's build it again. And there we go. Okay, that's our awesome application. Sweet. We go about our lives as happy people writing Go. But, maybe you've written enough Go applications now that you've never seen a main function that's just 4 lines. It's actually more like 400 lines. Or if it's not 400 lines in the main, maybe it's calling a function that's somehow 400 lines, putting all the various pieces together. I once worked on a program that had 400 lines in main, and that was pretty tough. So here's what wire does. Let's make this more interesting. So we don't want to be in the business of writing all this complicated setup code. Now, again, this is a super small contrived program. You would never use wire for this, okay? So this is kind of like the stand-in for that very big complicated program with a very big dependency graph. So, you know, again, the contrived thing like I was mentioning. So let's instead do something like this. Initialize event. You can think, I'm going to call it initialize event. You could call it whatever you want. It's sort of like set up the world. Build the world for me. Go get all the things, make them. And then when you're done, hand me back the piece that I need, that my application, whatever, and then run it. So wireland starts like this. We'll make a new file called wire.go. Again, you could call it anything. The convention as it is to call it wire.go. And we'll say initialize event, and it's going to return an event here. And for now, we're just going to do that. We want to make sure our compiler is happy. Compiler is our friend. Now, this is where it gets a little different. So we're going to make an invocation to wire.build. And we're going to provide wire.build all the various constructors or initializers that we just defined. So we know that we need a new event. An event needs a greeter, so we need to tell it how to build a greeter. And then finally, we need a thing that will tell us how to build a message. So there it imports wire. You see the import statement there and you think, oh man, I don't want to bring in some random tool that's going to like take control of my world and lock me into a thing that I don't like. Wire is not a dependent, as we'll see in just a second, wire is not a dependency of your application. You can have your application running. Wire is not there. Wire is just a tool to kind of get you going. And I think that will become clear in the next step. So we've made this invocation to wire.build and passed in all the initializers. So now let's see what happens here. So we'll run wire. And it's kind of all over the place here. But we get this nice error message. It says, initialize event, no provider found for string. So in wireland, there's a notion of injectors and providers. Those are nice words for provider. You can think of as just initializer. It knows how to make stuff. An injector is this special function that can build the world, that can take in all these initializers and then hand you back the thing that you're trying to build. So this thing is complaining. It says, I need a string. Well, why do you need a string, wire? Well, I need it because new message needs a string. And you can see it kind of works its way down. Well, then greeter needs a message, and event needs a greeter, et cetera, et cetera, et cetera. That's a long way of saying, or here, that's not going to work. Over here, we need to provide that nice message that we made. Oops, go Silicon Valley. Okay, so let's come back over here and say message is a string. So this is really interesting. What wire will do is it will see your initialize event, an injector, and it will see that you're giving it a string. And it will also see that you want an event to come out, right? So it's kind of like a little, here's the input and that's the output. And what it will do is it will sew together all the kind of initializers in the middle such that it takes in the things that you give it and it produces the thing that you need to come out of the function. So we've done that. Let's run wire again. So that worked. And you'll see here now, aside from the go.mod and go.sum, oh, I'm sorry, this side's cutting off. Let me fix that real quick. So you can all see this. There, is that better? Okay. So you see that aside from the module stuff, we have our main.go, which we know about. We have our wire.go, which we were just running. We also have a wire gen. So what wire's done is it's done its analysis of your injector and it's produced a wire gen file. Let's take a look at that. So here's wire gen. And you can see that it's taken your injector and it's filled in with all the guts. And this is more or less the code that we would have written. So one of the nice things here is, just as a kind of little side note, if later on down the road you're using wire and you think, this wire thing, it's really not working out, I do not like it, I want to delete it. you got your code right here. It's more or less the code you probably would have written. I mean, you might rename main message and main greeter and main event to, M, G, and E or whatever. But the output is just plain old Go code. For those of you who've already been working in big Go applications and are reaching for tools that give you dependency injection frameworks, you might be aware of the library that Uber's written. You might be aware of the library that Facebook has written that do this. The big difference between Wire and those two frameworks is Wire is a compile time dependency injection tool. It's basically code generation, such that if you make a mistake, your compiler tells you. The tough thing about runtime is if you make a mistake, you ship it to prod, you're having a great evening with your friends, family, whatever, and your pager rings and says, oh great, the code's broken. I like the compiler complaining at me and not, the pager telling me that. So anyway, we've put all the pieces together. We have our initializer event. Let's do one more thing. Let's build it. So we have this other problem. We've got these initialize event declared twice, right? We declared it once in wire.go, and then we have it in wire.gen. So let's fix that. Wire uses build constraints. You can see that the wire gen produces wire inject. So we'll just provide the inverse of it. And now we can build our program, we can run it, and it works. So that's kind of like a 30,000-foot view of Wire. Honestly, this is such a small program, it's pretty boring. You would never use it for a small program, but again, if you have a much bigger system, sometimes it can be nice to have a tool to generate you. I'm going to give you this. I'm going to give you my, API password or whatever, my API secret, and I'm going to give you this, that, and the other, and then I want you to hand me back a my cool app instance. The next thing that some of you might be thinking are, well, my initializers have the possibility of failure. What about that? So let's take a look here. So instead of initialize event, let's say that, maybe the greeter could be grumpy sometimes. And so therefore this initialize event could fail. And if it does, let's just say it failed. And to do that, let's say, in this case, we'll say that our greeter is potentially going to fail. It could be any one of these, but we'll do greeter. And just to satisfy our compiler, we'll say this. Grumpy greeter doesn't work today, or whatever, some kind of error case. So when you're writing this initialization code, it's kind of like a first-time cost. You pay the price once, you write all the initializers, and then you're done, right? You walk away. You don't have to worry about it again. Yeah, Wire makes that easy, but why bring in a tool to just save you maybe 15 minutes worth of work? Well, the piece that I personally think that Wire is a little more interesting, aside from just the initial code generation, is the refactor piece. I found myself in the position where I have this big complicated dependency tree, and I realized, well, these two dependencies up here that I'm passing into this third thing really don't belong in the third thing. They really belong, in the fifth thing down here. Oh, but man, now I'm going to have to edit 4 files, and I'm a lazy programmer. Can't I, isn't there an easier way? Okay, well, maybe I won't refactor it. I mean, I don't know if the rest of you have had that feeling, but I certainly have had that feeling. And I feel like this is where Wire shines. So in this case, I'm just using a very small error return, again, to keep our example as small and direct and concise as possible, because after all, we did all work, most of us, I imagine, worked all day, and are a little tired, at least I am. So we're just going to focus on error. So we want to add an error return value in all this. So that's all we do. We add an error to the initialize event. We run Wire again, or because the Wire gen has already been created, we can just run go generate. So we have a little problem here. Let's see here. Let's see, wrong number of arguments in main, 9. Let me make sure that's written. Yeah, right there. Again, the compiler is your friend. So we run go generate. It's produced this. And here, now all of a sudden, this piece is just there. So again, we wrote a tool that writes 3 lines of code. Whoop-de-doo, I don't care. Actually, this is quite nice when you have like a lot of code. And if you go back to the context of where Wire came from, in Go Cloud land, where maybe you've written like a lot of initialization code to get set up with Cloud A, it's quite nice to have an automated tool that can then you make a few changes and then run a Wire and boom, you've got setup world and Cloud B. So that's kind of the context of where Wire came from. But recently, we've realized that there are people out there who want to use just Wire without Go Cloud. And so that's why you'll notice here in the import path, just recently, I think Ross did this yesterday, hopefully for my presentation, moved it out to its own repo. So now you can pull it in if you want to separately. So that's a very rough overview of Wire. Obviously, there's a lot more. If I'll come back over here to the README. There is a, let's see here. Here's the README. I've just shown you the kind of like very basic features. There are a number of advanced features. Well, let's see, where did all that like advanced initialization stuff go? Oh, docs. Okay, yeah. So if you dig around in the docs, you'll find that there's a lot of more interesting things. So for instance, if you have an interface that you always want to bind to a particular type, if you want to have a value available to your various injectors, there's a number of interesting things that Wire can do beyond that. So I'd say take a look. Also, again, if you're curious about this, there's the blog post. It's just blog.golang.org/wire that you can read. It kind of explains more or less what I've said, but maybe more succinctly, more clearly, and more elegantly. That's a good place to look. So I think that's about 20 minutes. Maybe it's closer to 15. I don't know. That's where I'm going to leave it. That's it. Thanks, everybody. Thank you. Yes. Oh, and I understand there's some gophers.
There's some gophers. Yes. You don't get a gopher if you jump there in.
Okay. Yeah, so let's take a look at this. And the good news is Ross, one of the people who wrote a lot of this, is here, so let him take all the heat. Do you want to answer this question? Okay, all right. All right, so let's say we have this value going into message. Let's say that we also want to, for whatever reason, we want to provide it to the greeter too. Is that what you're thinking? Okay. So something like that. And the greeter does something with it. Let's just see what happens. I'm learned by example. So seems to have worked. Now you can see here that it's doing the right thing, that it knows how to handle that. It's passing it to both values. Oh, I see. Okay, so here's the little tricky thing. Because there's no way to look at the type system and understand, the person writing this code wants string A to go here and string B to go there. I think the recommended best practice is to wrap that string with a type alias. So for instance, maybe you want to have like a sponsored message. Maybe you want to have a friendly and sincere message, right? What you do is you declare a type that really just is a string under the hood, but has a distinct type, such that when Wire's trying to figure out the dependency graph, it knows that, oh, this official message goes over here in the official greeter, and the friendly message goes over to, like, the friendly greeter. Does that make sense? Yeah, I mean, that's it's kind of a trade-off, but if you think about, like, how might you go about implementing Wire, it's like, okay, well, that's probably what has to happen. You bet?
I've been waiting to do this all night. Can I...
And that's a purple gopher. The purple gophers are very rare, so take good care of that.
So my question will be, it reminds me of the Dagger for Java, right?
Exactly.
So what's the design goal of Wire? What's the roadmap for the next step? So right now I can see it can be really useful. Say you should be using, we can apply Wire to like partially of the code base, like where all the initialization was happening. or it can be really used. I can see how it was extracted from Google Cloud, because I mean, you have S3, you have the equivalent of the Azure and Google Cloud. You want to have your code to be not changed and still be run there. But it can be useful to generic, right, code base. So that's why I'm asking is that what's the next stage? I mean, is there anything like planned out to make it more like usable, especially like a go-to? Right now is like under discussion. There can be like syntax change, which like Wire can be built into the compiler to enable some of these cool features. Thanks.
So that's a question for this person right here. Go for it, Ross.
So yeah, just a little bit about me. Hi, my name is Ross Lights. You'll notice in the commit history, I've done a lot of things on Wire. There's a couple of folks here that have also contributed to Wire as well. So it's a good question. So first of all, kind of the first aspect, yes, there are a lot of similarities between the approach that Wire takes. With Dagger, there was actually a lot of, when we were developing Wire, we did actually reach out to the Dagger team, talk with them, and they were really thrilled to see, some of the, same ideas going in. But it really was one where we wanted to make sure that what worked well for Dagger in Java, there's many things where there's common concepts between Wire and Dagger and other dependency injection systems, but Go's type system is very different. There's a lot of things where there's a lot more things in Java of being able to do annotations and other sort of things there, and having modules and everything else. Whereas Go, there's no equivalent to like classes and these other things. So a lot of the design goals of what we were trying to do is build something that works to solve, sort of the same area of problems, but not necessarily just like, hey, we're gonna, pull everything over just in there. I think sort of the second part of your question is then what's the roadmap ahead? What's the future? Where is Wire, intersection with, potential language features of Go? I don't see it as likely that, I don't think that it's going to be the case that Wire is going to be like really tightly integrated into the language, whatever. That's just, I think a lot of what's interesting is that we're able to take a lot of the great static analysis tools that have been built by Alan Donovan and the team in New York, and take those elements of static analysis and be able to do interesting things without having to change anything about the language. And in fact, there's a lot of this approach of having it be a separate tool, a separate preprocessor, allows us to do a lot more experimentation a lot more quickly, of being able to, this approach of having these sort of pseudo marker functions that you see in here, of having wire.build be like this totally, crazy thing that doesn't actually do anything but is used totally as kind of an annotation-like thing, is actually something that we'd never thought of before, and was actually one that, we think actually would be kind of a cool pattern to have other, similar code gen tools be able to do. So part of this might be an interesting way, for other tools to start using more rich information from the type system forward, but we don't have any concrete plans for, integrating into the language. And a lot of what we're doing going forward is just making it so that we're able to help enable the sort of applications we want people to build with GoCloud.
Hi.
I apologize, that was long-winded.
So, I'm Sundar Vincent from the InfoSec. The question is not specific to this talk. In general, I'd like to get your opinion or the recommendation on the static or dynamic analysis tools you would recommend for Go, or you guys, Google, you guys are using. It is for both audience as well as the speakers. You guys know there is some open source tools, but do you recommend anything for the security analysis?
So you're talking about like static analysis for, but you're talking, static analysis can refer to a number of things. So you're talking more like for security.
Yes.
I don't actually know any offhand. I don't want to, you know, start spouting crazy things. I've heard that there are tools out there for being able to do similar checks. But there's a lot of the same ones from like C++.
So what you guys are running? If you can share what Google runs.
I don't know enough to be able to say anything with confidence, so I apologize.
Okay. Or anybody from the audience, if you have any recommendation, let me know.
No? Sure, someone. So I'm out of Gophers until the last segment. I have some talks, but since we were short, I'll go ahead.
Oh no, the Gophers are gone.
Unsponsored question. But I have just a general, like I don't work in Silicon Valley, but is this project something you've done on your own time, or was it like sponsored as like, oh, we need to solve this problem and let this group of guys work on that? How did it come about?
Yeah, so so I work on as part of the Go team. You know, my paychecks come from Google, but this is something that we are releasing. Specifically, it's been kind of a sub-project under Go Cloud, again being developed by the greater Go team, and you know, this is totally an official thing. This isn't like a, you know, out there sort of thing. No.
For a little bit of context, if you come over here to Google/Go-Cloud, this is where, yeah, Wire is still here. In fact, it was just split out. It was initially developed as a tool to make the world of like setting up the world on Cloud A, and then say, you know, I really want to be running on Cloud B, to make that a seamless transition. Wire was a tool, I think, I mean, again, I'm standing next to the person who wrote a lot of it, but in my like understanding, that's where it came from. So part of a tool, part of this idea that we want to make Go this like portable ecosystem, have this great like ecosystem of libraries that it makes it very easy to move things around, not worrying about the underlying infrastructure and focusing on the applications that all of us are building.
All right, so I think we have time for...
So I want to know, where is the injection happening? So with 14 years of Java behind, whenever I see build, I think of the builder pattern. Are we doing something similar to the builder pattern, or are we... I couldn't figure out where is the injection happening. Like, we don't have annotations in Go, but then if I have to inject a few more, say, class equivalents in Go, how would I do that? Or like, I have to keep extending the parameters or increase the number of parameters? Or
there are a couple ways to do it. So let's just say naively that we want to have like an event coordinator to continue on with this sort of little toy program. It would be a matter of going over to your initializer and say, well, an event doesn't take a greeter, it takes an event coordinator. And then the event coordinator takes a greeter. So then you go and look at your various initializers for your application code, and you make sure that each initializer gets the dependencies that it needs and it produces the thing that it's going to produce. In that case, it would just be a simple matter of saying new event, coordinator. I'm going to elide the rest of that. Now, that's one approach. There's also this notion of provider sets in Wire, where maybe you don't want to have all your initializers piled in this big, 100-line long thing. You want to have, this is my provider set for building, HTTP outbound stuff. This is my provider set for building, caching stuff. There are ways to do that, and I think the best thing to do in that case is to come over to the docs and dig around in here, because tonight I've shown you just a very kind of introductory, very gentle, this is Google/Wire introduction. So there's a lot of more interesting ways to approach this problem.
You mentioned that it was very useful for dependency analysis. Do you have a way to produce a graph that you can then have a look at? Or
that's a great question.
Yes, I'm feeling this one.
I mean, if you took dependency, I'm gonna look for a graph.
Yeah, so there's an open feature request. All of the data is there for being able to do that inside of the program. We just haven't figured out the right way to expose that yet. So I guess, yeah, sort of going back to the roadmap question, there's plenty of other cool features and, things that it's like we don't have an immediate need, but if that's, something that people are interested in, give us feedback and yeah.
Yeah, so part of the talk is just to guide us through the example. Because when I first learned about dependency, when Ross was telling me about this tool, I thought, I don't know what this guy's talking about. And it's really not, it's pretty simple, right? Like we've been through it, you guys all understand what wire is. But the other part of it is, try it out. If it seems like a tool that would help you, try it out. And also contribute, because it's still kind of early days. We're interested in building up. So if there's this sounds like what you've just proposed, that sounds fantastic. I would love a tool that says, here's your dependency graph, and this is why your application is very complicated, or, print it out, and now everybody understands what your app's doing, or whatever, So open an issue if it's not already there. It sounds like there is one. It's a great question.
So I think there was one more question, or are we good? There was one more question over here. No?
Yeah, right.
Could you repeat the question, just so everyone...
So let's see, that's a very interesting question. So in the example that I've shown, it's very simplistic, right? Like one thing comes in, one thing goes out, it's all very lined up. If there's any ambiguity, in other words, if there's any combinations, like if wire could go down this path and still produce your artifacts, and go down that path and produce an artifact, wire's going to say, I don't know what you're trying to ask me to do. So what's a good example, like providing a couple strings?
So if you go back,
do you want to?
Yeah. Well, I can't.
Okay.
I can't type, so
Okay,
I'll dictate. So if you go back over to the main.go, where you had all the functions there. So if we add something that's cyclic per se, so let's say the new message also needs a greeter as one of its parameters. Perfect. Now try running wire. Wire should hopefully complain at you. Yay, cool. So all of the inputs to the graph, the way that it's building up is entirely based on type identity. So each of the nodes are individual Go types, and if they are distinct, then they become distinct nodes. It is smart enough to figure out, it does a topological sort and, goes through and figures out what is the correct sequence of things. The way that it then does generation, if it finds that there's a cycle in the graph that you've established, it'll give you a nice error message like this saying, hey, this is actually totally impossible to construct, please fix, and gives you the sequence.
Yeah, that's a good question. Let's see here. Probably in the guide. If you come look at the guide here.
And the question was, just so everyone hears, of that if there's something where it can't figure out how do you annotate, how do you give it more, information of things.
So for instance, binding interfaces. Let's say your initializer takes in an interface. It doesn't want to know about the concrete implementation. It just wants an interface. And then maybe there's a number of things that can supply that interface. There are ways to say, hey, if anybody asks for a fooer, let's see here. Hey, wire, if anybody asks for a fooer, understand that that means give them a bar. So if this tool seems interesting to you, I would recommend everybody to take a look at the user guide. They'll show the basics, which I've walked everyone through here tonight. But there are a number of advanced features that I haven't even really covered. Binding interfaces, struct providers, a lot of other interesting kind of things that...
The bindings are compile time. Everything that happens in Wire is going to happen as part of that initial code generation. Yeah, I mean, one of the design goals for Wire 2 is that it should be the case that if you design a really good idiomatic Go API, in general, if you just pass all those functions in, Wire should generally be able to figure out something reasonable to do with them. Or at least that's the goal. That's the intent. whether or not it does that, try it out on your code base.
Yeah, so I feel like we've been up here yapping at you all for quite some time now. Feel free to email me. I'm comment Google. I'll be hanging around afterwards if you have more questions. Thank you so much. Try it out. Give it a try and see what you think.
All right. Thanks, Ino. Thanks, Ross. Appreciate it. Devang, why don't you come up and get set up? And you can bring the mic back to the back. Thank you. So our last and final. You haven't been mic'd yet? Okay. Our last and final talk tonight is a PayPal talk. So very happy to share our experience and how we're using Go internally. And this evening we have Devang from our developer experience team, who's going to share how we're using Go and gRPC in our release management infrastructure. So Devang is sporting a very impressive mustache. We have 1 day left of this mustache.
Thank you. Yeah, it will be there only for 2 days. If anyone wants to see my mustache, please feel free.
For November?
Yep. Is the HDMI?
HDMI is... Oop, where'd it go?
It was there, right?
So, when we set up?
This should be good. I guess so.
Oh.
No.
Yeah, when we tested it was... RT could...
I have the old
HDMI cable that was
HDMI
up
cable.
here
HDMI
when we set up
cable
is no longer here.
It was here.
Ah, we switched
Oh,
it
it was
out
not
because
working?
of that.
Yeah, USB-C. It's an old Mac.
The Google team comes with Gophers, takes all our HDMI cables. What are you going to do?
It's an old Mac. I just need this one, but there is no connector for this. You are using this one? You are using this one?
Not that one. I have the same Mac as you.
Oh, then how did you connect it?
He just walked out of the...
Nothing over here. Yeah.
I don't have a VGA cable, right? I do have an adapter. I don't have it in my bag.
I'm connected from this to
Right?
regular DVI.
Yeah, I don't have a VGA.
When that should work. Okay, RC.
Yeah, it just like left as soon as we were getting started.
Thank you. No, this we have, but we don't have to connect this one. Wire to connect to this. Yeah. I can connect this, but there's no wire to connect over here. Oh, there. Thank you. All right, that's all. I will connect that later. Yeah.
Any video in your presentation?
No, no video.
All right, here we go.
Thank you.
Devang?
Thank you. All right. Good evening, everyone. First of all, I'd like to thank RC and Dan for organizing this wonderful Go conference meetups. And thank you all the audience and staying up this late which is already almost night, and my third presentation. All right, so I'm going to present in this session, I'm going to present about how do we go about building this product, that's Rubicon. It's a DevOps tool in Go and gRPC. So I'll be focusing more on the gRPC part on this presentation. So let me introduce us like who we are, about the team. I'm a lead engineer for developer experience platform, and we are a team of size of 10 people. We actually are focusing more on developing the DevOps tools, and we are into the code propagation automation, developing the tools around it. What we do over here, we are supporting 4,500 developers across the PayPal, 2,500 microservices, and 2,700 applications. That's a huge, large, scalable application in PayPal. And what our product Rubicon supports, more than 500 code propagations per day. And its capabilities is to support cross-organizations integration. Agenda. First, I'll quickly have a quick go through about the product, Rubicon product, what we developed. Then we'll go about technology stack we used. gRPC, more into gRPC, and about a little bit on data store, and then a quick small demo. What is Rubicon? Policy check. Rubicon is a internal tool developed by our team, which is to validate any manufacture or any builds or any code which goes live, propagates from environment to environment. We have the policy checks to enable release criteria enforcement. Release criteria is a multi-level, flexible, and scalable. So that means that policy checks can be defined at a multiple level, like application components, the governance body, anyone can define these policy checks. And it's flexible enough to handle any types of validations. Its purpose is to reduce preventable or reoccurring bugs which can occur at the live site. We have developed this product in such a way where it's a plug and play. Any developers, any component who wants to have its own specific policy criteria, they just have to implement it and plug it into this framework. So you don't have to, it's easy to inner source by this, and you don't have to worry about way of the deployment, again read, build, and redeploy, verified, anything else. We have starting with around 500 release validations, as I mentioned, per day, but it's scalable to thousands of per day. Its capabilities is to support cross-organization, as I mentioned. So it's not only PayPal core, but we can support Venmo and Braintree as well. Technology stack. We are using Go, services built in Go. We are using gRPC as a communication protocol, and we are using Google's Cloud Data Store as a backend. Why Go? It's fast. You always know about the Go, most of you. It's fast execution, first-class support for concurrencies. As you know, it really provides very good support for concurrency, Go subroutines, fast development cycles, and supports the garbage collections in build. It has the most comprehensive set of built-in libraries, as suppose like a testing or name it, it has everything inside it. There are outside third-party libraries, but it's always recommended to use all the Go built-in libraries. It is compact code, less bloated ecosystem. It's derived after learning from other language pitfalls. Why gRPC? This I'm going to cover more in the upcoming slides, but it's high performance, open source, universal RPC framework developed by Google. It's cross-platform, and it's building native Go. And by Google Data Store, it's highly scalable NoSQL database, and it supports atomic transactions, which is NoSQL. This is an overview diagram of architecture. So we are developing, like Google Data Store is a backend, and our product is building Go and gRPC. And we are supporting our customers, which is developed in 3 different languages. We have like the customer developers or clients consuming this service is on Java. We have some customer which is in Python and some are in Node. So we are supporting all these 3 customers, clients. gRPC. gRPC is very simple. It took us literally few days to get started, like just 1 day to get started with. Like we implement messages, including all defining all the messages, which is very simple. It's just protobuf files and defining or exposing the methods, defining the contracts in protobuf is very simple to implement it. We have like, it's supposed to, as I mentioned earlier, it's supposed to cross-platform. So cross-platform in the sense that gRPC, since it's like a protobuf file, the contract, gRPC has this generator, proto-compiler, which can be compiled into most of all the languages, like C++, Android, even for Android or Java for Android, then Objective-C, Go, of course, Python, Java, JavaScript, you name it, and it's there. It's quick start. It just you need to install gRPC Go libraries. That's very easy to install it. It supports bidirectional streaming and security. By this, like streaming, gRPC, the wonderful part of the gRPC is it has the simplest part is like unary RPC. Has like one sends a request and you get the response, server and client communication. Then we suppose server streaming, where server sends the responses in multiple streams, where client sends the request in one stream. And we have like client streaming, where client sends in multiple streams, and then after the processing, it's server sends in single stream. And then it's binary directional stream also, where clients give multiple requests in multiple streams, and then server can respond back in multiple streams as well. So it's very fast. And security. Of course, paper being the most important priority for paper security, it supports credentials and it's secured, can be made secured, just like any other APIs. Interceptors. This is again another beauty of gRPC. Interceptors are like every request, it intercepts and executes a particular piece of code. So let's say in our product, we have implemented authentication and logging as interceptors. So any request comes in, it gives us an authentication token and we authenticate it, as well as for logging initialization. Also, we use an interceptors over here. Now, gRPC has lots of contracts and conflicts within like, hey, why you want to go with gRPC, REST, also many applications use REST, and so why we want to go with gRPC. We have gone through this journey. When we developed this product, initially we developed in REST APIs, and then we started, hey, let's try it out, why not gRPC? Let's try it out. And initially, as for our personal experience, initially we found that, okay, maybe gRPC is little different, it's a little tricky to use, but then we found that it supports so much better experience that yes, we should go with gRPC, and I can highlight some of them. So gRPC supports HTTP2, says REST supports HTTP 1.1. So HTTP2, I think as most of you know, has been doing HTTP2. So HTTP2 allows lower latency connections, hence it is faster. HTTP also supports bidirectional connectivity and asynchronous connectivity, which again makes it very fast and improves the performance. Then messages versus resource and verbs. In REST, as you know, that you can have limited primary functional calls like get, put, patch, delete, post. That's much it. But in gRPC, you can define whatever function calls you want. You can define it. You can make it synchronous, unsynchronous, unidirectional, bidirectional. You can play around with it, whatever is per your requirement. Strong typing versus serialization. That's another cool thing over here. So the REST paradigm doesn't mandate any structure for the exchange payload. it is typically JSON. Customers don't have a formal mechanism to coordinate the format of the request and the responses. Oops, sorry. So it's because of this, whereas in gRPC, it's strongly typed. So the methods or messages which pass from the client server to client and client to server are already in the object form, and this object is already serialized and get passed from client to server and server to back and forth. So basically, sorry, I think I am wrong. Okay. So basically, because of this, and also another main important is streaming versus request response. So in again, gRPC, it's a streaming. The message gets streamed across the HTTP2, and whereas in the REST place, it's just a request and response form. So basically, in gRPC, since it's already the method call, you don't have to deserialize or serialize any application or code. You don't have to do that. It's already taken care. It's already serialized. It's formed. Where messages are formed, passed in serialized form. Whereas in REST, the application, the code, they have to first deserialize from methods to JSON, pass it, and then the consumer will have to again serialize from JSON to back to the objects. So that's again increases the latency, and also it increases maybe error prone. So these are the reasons why we went forward and went ahead with gRPC. I can show you quickly some protobuf just to understand. So gRPC again advantages like it comes with built-in compilers which will compile for you, generates the stubs and clients, and you are ready to use it right there. So I can quickly show the protobuf. Okay. First of all, let me show you this. So this is like a sample. This is a protobuf which we have. So this is like a messages which we define like request. Zoom in. Okay, sure. Yeah. Right? Sorry? Oh, okay. Where? The protofile. Yeah. So this is the protofile which I was talking about, and this is in this protofile we define the methods. Let me show you. Yeah. So these are the methods like add application or add policies and validate manifest. These are some of the methods which we can define over here, and it accepts the request and response methods as an input and output parameters. And this is how we defined. Okay, these are the messages which we inject in the methods, RPC methods. Sorry? Yeah, it's okay. Yeah. Yeah, and I think we need some plugins for Proto actually. Actually, I mean, in my other the tool that actually comes with a Proto plugin as well, which comes with the highlighted code what you are mentioning too. Going back to presentation. So there are some limitations of gRPC. I would not say as a limitations. There are ways to come over with it. So it's actually not, first of all, it's not applicable for browser-based application, of course, because it's an APIs for services. This is mainly used for the services. It does not support all the languages, but most of the language it does support, like maybe some other language, maybe homegrown language or something. But even so, not supported means it does not have auto generation of the code for stubs and everything. But you can always go ahead and generate it by yourself, create the stubs and methods by yourself. That doesn't stop you over there. Last one, manual testing can be a pain. But as a paper, like we don't believe in manual testing. Like we try to achieve 100% automation. So automation testing always helps over here. But manual testing, like say as in against the REST, like in REST you can just do curl or postman. It's easy to just test quickly. That's not feasible, possible in this case. Okay. So client management. So we have the service, we have the protobuf. Now we want to serve these services to any of the clients or customers. These clients or developers, maybe as I mentioned, like it may be like Java, maybe JavaScript, maybe Python, maybe C++. There can be a number of clients. So one way is to provide them the protobuf file and tell them, hey, there's the contract, here's the protobuf file. Go ahead and generate the clients. Go ahead and generate the jars and use it. We found that that's not a good way. That's not a good approach. The customer, we don't want to add any pain to the customers or developers. We are in the field of developer experience. We want to have developers happy. So what we do is we will generate it for you. And then we thought, okay, we generate it for developers. I mean, every time we change, every time we generate the jars and libraries, that's not what we want. But what we did is we automated everything. So whenever there is any change in protobuf, so we, as I mentioned, we have three main clients, developers who are using services. One is some Java, Python, and JS. So for Java client, what we did is we create a CI, and in CI, like whenever there is a change in proto file, it will automatically generate, compile, and generate the stubs, and it will create a jar and bundle it in the jar, and we upload this jar into a Nexus repository. So Nexus repository is a repository internal to PayPal where all the Java applications uses this Nexus repository with as a library for repository management. So basically, we bundle it and upload to Nexus repository. For Python, we again call this proto compiler and generate the Python libraries, tar files, and push this tar file into our internal PyPy server. And this PyPy server is again the central repository for Python clients. And then JavaScript. Again, in JavaScript, we automatically create the JavaScript libraries, does the deployment, and then we manually push into NPM repository, because in our case, in PayPal, NPM repository is password protected username, so we do it manually into pushing into NPM repository. But rest, everything is all 100% automated over here. So any change in protobuf, it's there, the jars, libraries, the applications can just use it. So again, if you have like C++ or Go, even Go, or any library or any technology stack, you can automate it and push the libraries to them. And by this, they are all happy to use it. I can quickly show you the CI job for that. So yeah. So this is like a Java CI job we have. And I will just quickly show you the configuration, what we do. So, yeah, I will do that. Okay, so basically I had created one separate form file which for generate, it basically internally uses a Maven plugin. It also has its own built-in Maven compiler plugin, where we just call this Maven plugin and create stubs and generate the jar files. So this is the plugin which we created. It's in the POM file. I have to open it up, but I don't have it right now with me, I guess. But yeah, it's just a simple small POM file, which comes with a Maven plugin. So similarly, I have created a similar CI job for JavaScript as well as for Python. Next, like we also use a Google Data Store. Google Data Store, the reason why, because look at the numbers, we had very highly scalable product. Like it's we are supporting lot number of builds and deployable code to validate against. So we need a database which can be scalable. So Google Data Store is a better choice for us, or proved out to be, because it was highly scalable PostSQL database. It automatically handles sharding and replication, which again is good for performance wise. And also its capabilities like ACID transactions, SQL-like queries. So you basically get goods of both the worlds, like NoSQL and SQL queries, support SQL-like queries. So you can have, it's easy to call the queries again. And then I'll just quickly show one demo. Like I'll just show one demo where we have created, Deepak is over here. So we have created a nice dev runner. We are using dev runner tool, which is in Python, and that actually calls the services Rubicon service. And this is the command. So dr is just a dev runner where we say, okay, I want to execute the policy check. Oh, sorry. I'll zoom in. So dear dev runner, I will say policy check, and then I'll say, okay, inspect this particular application, and this is the build ID. So it will run and execute some of the policy checks which we have defined. And if I execute this, so it should come, yeah. So that's all success. Okay, all these policy checks are passed, like functional pass rate and Git owner count. We have some of the predefined policies over here, defined over here. Gets executed, and we say, okay, yeah, it's good to go, and the manifest is good to go live. Well, that's pretty much which I have. Thank you. Any questions?
All right, 3 gophers left.
Yes. So gRPC is like we use it for generates for the server files. So with gRPC we generate for the client libraries, for the client stubs for the client, so the client can use those stubs and then connect to and gRPC library as well.
Use kind of like REST, for example, you can use from the client side.
Yeah.
So can you use gRPC from the client side?
That's what I said. So gRPC basically creates stubs for server as well as for the client. So you just have to provide this library to the client, can depend on this library, and they will get all these stubs, and they have to just say, okay, connect to this machine, dial this machine, and then their library is already there. They can just use this library contracts or APIs to call the services. So it's just like you are calling your internal methods or local methods. It's just like you are calling the local methods. It's similar to that.
Okay, so you use them from the client side?
Yeah.
Yeah, okay.
I'm sorry, can you repeat it?
It's like a part of your, is it the usage of these Rubicon?
Yeah.
It's like a part of your build pipeline, and it's just like mandatory.
Yes, it's part of the build pipeline. It's a code propagation pipeline where wherever the code propagates from one environment to another environment, like say from QA to staging to LNP to whatever, and then live. So every stage we have the policy checks over there, that you have to go through this policy checks, and if satisfy those policy checks, then only you are good to get deployed into this particular environment.
And can teams run it?
Yeah.
When they just want it.
Sorry.
Can they run it by on demand? I mean, just by request.
Yeah, that's what I did in this DR command, dev runner command. I just ran this validations. This is actually called the Rubicon, which ran all the validations for me, and then I can call anytime I want. Actually, it's not only during the core propagation or something, but you can call anytime you want to call it.
Is this going to be just internal tool or?
Internal tool. So right now it is an internal tool, but we may plan to open source it. We know, but right now it's internal tool, and we are actually make it more generic so that we cover at least the Venmo and Braintree part of the PayPal.
I was interested in how you communicate the protobuf changes across all the clients, and how you manage like if a field's kind of deprecated.
So in CI job, automatic creation.
Yeah. Like
yeah. So basically in CI job,
like
we have something called as include filters, where you can specify, okay, if there is a change only in this file, then only run the CI job. Otherwise, don't run the CI job. So if I say only if there is a change only in proto file, run the CI jobs. I can show it to you if you want to interested in it. Yeah.
You pointed out very well the advantages of gRPC over the plain REST interface. Did you consider using Swagger?
Swagger, yeah, that's one of the things which gRPC don't have. So for documentation, that's one of the point which I missed. So the documentation part of gRPC, we just give this proto file, share the proto file. Proto file, we can put all the comments in the proto file, and it defines the contracts and what needs to be passed into that contract. It's all defined in the proto file. So we just share the proto file to the customers, saying that, hey, this is a contract. Just use the.
What I'm saying is that describes pretty much what you can do with Swagger. And
yeah, Swagger. Yeah, it doesn't support Swagger. I mean, there was one of the third-party library. We tried it, but there was no support for that documentation for like.
I think you didn't understand my question. So you have REST, and with multiple disadvantages, and you move towards gRPC. My question was, did you consider moving towards Swagger, which will still keep the REST interface, but we get all the advantages of type safety,
yes.
interface definition, and so on?
Yes. So, but gRPC provides more other advantage than type safety. That's HTTP2 protocol. Yeah, and what else? It generates the code as well for you. Code generator, where it's, we just proto, because defining the context in proto is much easier than coding anything, and the compiler, code generator will take care of creating the interfaces and everything for you.
Thanks.
Someone.
Yeah, actually, this question is more leaning towards the Go team. When can we use gRPC in browser applications, or is any planning to support it?
So gRPC doesn't support because it's the REST API. So I guess a browser doesn't support gRPC. Yeah. Web. Okay. Oh, okay. Nice to know that. Oh, okay. Good to know that. But yeah. Right now we are not in browser-based applications, by the way. So yeah, but it's really good to know. Thank you. Yes, John.
How did you deal with like load balancing with gRPC? I know a lot of load balancers don't support gRPC, so.
We are actually using right now Google's load balancing. Yeah, so I know that our Intel PayPal IV load balancer doesn't support HTTP, it's on HTTP 1. So we are using Google's load balancing right now. Or HTTP because it supports HTTP 2, Google load balancer. Yeah, thank you.
All right, well, I think that can be our final question for the night. Let's give it up for Devang. So, Arti, I know you've avoided being on the stage for most of the evening. Why don't you come up and join me? So, when are we back?
exactly. So our next meetup is at Netflix. Scott Mansfield from the caching team at Netflix has offered to host, and so pretty excited about that. There'll be one talk from Netflix, but we're still looking for 2 talks, so please submit talks, and we're happy to, host you. We also have a meetup scheduled for February. So there's all these companies are reaching out to me. They're like, oh, so I'm like, the next meetup at PayPal is actually in May because I'm scheduled out all the way till then, which is very exciting in South Bay. The February meetup is at an AI startup in Palo Alto called Liftoff. And the March meetup is possibly at cloud startup in Mountain View, Planet Scale. So, and then I was talking to Fetch Robotics, who also wants to host a meetup. So it's very exciting for us at South Bay. So hope to have many more. Also, I host the Women Who Go meetups here at PayPal and other places. And I'm just a little bit pitch for that. And those meetups are study nights. So they are themed. And we actually go through tech talks and we study, and it's, so the next one is on networking. And we're going to go through Filippo's talk on networking at GopherCon, and we'll also go through how the Go Network Polar works. So if you are an expert in networking and want to come and help us learn, please join us in that talk. We'd love to have you. And, so it's mostly women. And men usually join, and you're open to join, but mostly to maybe help us, support us, that sort of a thing. So that's the last thing. And thank you all for coming. Great to have you.
There are a couple more T-shirts here, so please feel free. And thank you very much for coming.